Okay, so let's talk about some of the basic properties of differentiation. So f and g are going to be functions, and we're assuming that they're differentiable, and k is a constant. First, the derivative of a constant is 0. The reason is because a constant function is a horizontal line with slope 0 everywhere. Since derivative is slope, we get 0. Second, the derivative of a sum is the sum of the derivatives. The derivative of f plus g is f prime plus g prime. Similarly, C, the derivative of a difference is the difference of the derivatives. The derivative of f minus g is f prime minus g prime. And finally, the derivative of a constant multiple is the constant multiple of the derivative. The derivative of k times f is k times f prime. These last three together you could call linearity. The derivative is linear. Okay, so now we can take the derivative of any polynomial. So for example, let's take the derivative of x cubed minus 2x squared plus 4x minus 1. I've been saying differentiate. Differentiate means to take the derivative of. Okay, so our rules tell us that I can take the derivative term by term because differentiation breaks up across differences and sums. So I'll take the derivative of x cubed, subtract the derivative of 2x squared, add the derivative of 4x, and then subtract the derivative of 1. Okay, so the derivative of x cubed is I bring down the power 3 in front, then I reduce the power 3 by 1 to get 2, and I get 3x squared. To get the derivative of 2x squared, I use the fact that the derivative of a constant multiple is the constant multiple of the derivative. I'll leave the 2 there, and I will just take the derivative of x squared. Bring the 2 down in front, reduce the power by 1 from 2 to 1, and since x to the 1 is just x, I'll just write that. And so I get 2 times the quantity 2x. This 2 comes from the constant, and this 2x comes from the derivative of x squared. Next, the derivative of 4x. Well, this is again a constant multiple, so I'll leave the 4 there. And then the derivative of x is 1. We already talked about the fact that the derivative of x is 1. It's the same thing as x to the 0. Anyways, so the derivative of x is 1, so I get 4 times 1. And finally, the derivative of a constant is 0. So 3x squared minus 2 times 2x plus 4 times x minus 0, which simplifies to 3x squared minus 4x plus 4. Okay, I would like us to get used to dealing with different variables, and I would also like us to get used to different notations for differentiation. So this is just another differentiation problem, but it's written a different way from the previous one. So I would like us to evaluate d dt of 3t to the 5th plus 2e to the t plus sine of t. First of all, this is the first time I've written d over d something where the something is not x, it's t. Why? This is a function of the variable t, so it only makes sense for me to take the derivative with respect to t. So that's why I write d over dt, means take the derivative with respect to t. Okay, now it's a sum of a couple of different things, so I'll take the derivative term by term. This first guy is 3t to the 5th, so I'll leave the 3 there and take the derivative of t to the 5th. The power rule says bring down the 5 and reduce the power from 5 to 4, so I get 5t to the 4. And I get plus 2 times e to the t. The derivative of e to the t is itself e to the t. Plus sine of t, and the derivative of sine is cosine, so we get cosine of t. Simplifying this, I get 15t to the 4th plus 2e to the t plus cosine of t. This time, let's let y be equal to x plus the square root of x plus 1 over the square root of x plus 1 over x. Let's find y prime. Again, this is just a differentiation problem. I'm just wording things slightly differently, but there's really no difference in terms of the basic question of what the problem's asking you to do compared to the last two questions. Okay, well, we don't have rules for dealing with roots or reciprocals of x. However, we have the power rule, and we know that we can always rewrite roots or reciprocals of x as powers of x. So the first thing you do when you're trying to take the derivative of something like this, that involves roots and reciprocals, is typically to rewrite it as powers of x. So that x plus x to the 1/2 is the same as the square root plus 1 plus 1 over the square root is x to the minus 1/2 plus 1 over x, which is x to the minus 1. Now I differentiate. And this is all just the power rule, more or less. So y prime is the derivative of x is 1. The derivative of x to the 1/2 is I bring down the 1/2 and then I write the power 1/2 minus 1. The derivative of 1, which is constant, is 0. The derivative of x to the minus 1/2 is I bring down the minus 1/2 power. Then I reduce the power by 1, negative 1/2 minus 1. And finally, the derivative of x to the minus 1 is I bring down the negative, and then the negative 1, and I rewrite, or I change the power to minus 1 minus 1. Okay, now let's start simplifying. When I'm dealing with fractions or negative numbers and exponents, I like to be careful sometimes and write minus 1 instead of just trying to do the subtraction in my head. So, when I simplify, I get 1 plus 1/2 times x to the minus 1/2, minus 1/2 times x to the minus 3/2, minus x to the minus 2. That's good enough, but if you want to make it look a little prettier, you can rewrite it as 1 plus 1 over 2 root x, minus 1 over 2 x to the 3/2, minus 1 over x squared. Okay, so, well, there are 4 questions this time. Question 4, let's let f of x be negative cosine minus 2 sine minus 3 e to the x. Evaluate df dx of x. What does df dx mean? Again, that just means to differentiate. This is just different notation, but it's the same basic idea as the previous problems. Just take the derivative of this expression. Okay, so now let's apply the knowledge we've learned. First, let's think about this in the context of tangent lines. So let's find the equation for the tangent line to the function y, or to the graph y is equal to e to the x minus x at x equal to 0. Well, to get the equation for a tangent line, I need a point and I need a slope. Well, the point that I'm given is when x is equal to 0, so the y-coordinate corresponding to that is e to the 0 minus 0, which is 1. How do I find the slope of the tangent line? Well, the derivative gives me the slope at any point. So first I compute the derivative. The derivative of e to the x is e to the x. The derivative of x is 1. So e to the x minus 1 gives me e to the x minus x gives me the derivative e to the x minus 1. At the point I care about, which is x equal to 0, to get the slope, I plug in 0 into the derivative. So my slope is e to the 0 minus 1, which is 1 minus 1, which is 0. So using, say, the point slope form, I don't need to use that here. I could use other forms here, but whatever. I get y minus 1 is equal to 0 times x minus 0. That's just the line y is equal to 1. It would be informative for you to graph out the equation e to the x minus x and to verify that at x equal to 0, we indeed do have a horizontal tangent at y equal to 1. Okay, and finally, a physics type example. Let's let s of t equal to 2 plus 30t minus 4.9 t squared be the height of a ball in meters t seconds after I throw it up into the air. Let's find the instantaneous velocity 1 second after I let go of it at time t equal to 1. Well, the velocity is the derivative of position. So I take the derivative of this guy. The derivative of 2 is 0. The derivative of 30t is, well, I leave the 30 there, and the derivative of t is 1. So I'm just left with 30. Minus 4.9t squared. Its derivative is 4.9 times the derivative of t squared. To get the derivative of t squared, I apply the power rule. I bring down the 2. I reduce the power by 1 to 1. I simplify, and I get 30 minus 9.8t. Finally, I just plug in t equal to 1, because that's when I'm looking for the velocity. When I plug it in, I get 30 minus 9.8, which is 20.2 meters per second. This is so much easier than what we've been doing. Great. I'm glad that we have these rules of differentiation, finally.